Lesson 74, Scientific Notation. Scientific notation is just a mathematical shorthand. It is a way that we can condense really large numbers and write them quickly, or we can take really small numbers that have lots of decimal places and condense them into something smaller. So we can write them quickly as well. Let me show you what I mean. Let's say I have a number. Let's say I have 316 billion. That's going to be 3 sets of zeros right there. Okay, 9 zeros. I don't want to write all those zeros every time. So instead, what I do is I figure out my scientific notation for this number, and I'll write that instead. Scientific notation is just a fast way to write all those zeros or all those decimal places by using an exponent. We know that if we take 10 and we put it to any power, let's say we put it to the 4th power, we know because of the nature of 10 times 10 that the exponent on 10 is the number of zeros that we'll end up with, right? So if we said 10 times 10 times 10 times 10, that's the same thing as 10 to the 4th. We end up with 4 zeros. We have the number 1 and 1, 2, 3, 4, right? So 10 to the 4th equals 10,000. So scientific notation takes advantage of this knowledge and the use of an exponent and reduces this to a decimal that can then be multiplied times 10 to a power that represents all the spaces that it will expand to. So for instance, this, if we write it as 3.16 times 10, we count the spaces to the decimal, to where we want to put the decimal. In this case, the decimal starts here, so we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is where we want to put the decimal. So this would be 3.16 times 10 to the 11th power. And we know by looking at this that we would just take 3.16 and would move this decimal 11 spaces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then we would insert our commas where they need to go. That's the same number as this right here, right? All you need to do is make sure that when you count your zeros, you include these 2 decimal places here. So always move it to where you want the decimal. And typically what we do is we have one whole number and the rest is behind the decimal. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And you'll get to where you can just go 3, 6, 9, 10, 11. And it'll be quick for you once you get the hang of it and you get used to seeing it that way. And people who use it all the time in certain sciences, they just know because they've used it all the time. They know what that number is. They know that 11 spaces is 100 billion. They know that 10 spaces is 10 billion. They know that 9 spaces is 100 million. They've used it so much that this is not something they have to figure out. They just know it. It's a memorization technique. It's like your multiplication tables. They just know it. And with practice and a lot of use, you will just know it too. But for our purposes right now, you can just count and it'll be fine. So what if we have a really big decimal place? How does that work? Let's say we have this number. We have decimals, we don't have commas to help us out. You know, when we have whole numbers, commas help us to see. But with decimals, not so much. So we have to go through and we have to figure out, okay, tens, hundreds, thousands, 10,000s, 100,000s, you know, whatever the spaces are, we have to go through it and figure it out. And that can get monotonous. So the other way to do this is to go backwards. And when we go backwards, let's just pretend we have a little number line right here. And this is 0. And with this one, our number got bigger and our number was positive. Our exponent is positive, right? It's positive 11. So we end up with 100 billion. And that's what we multiply by. Well, when we have decimals, our number is smaller, isn't it? We want it to go smaller. So we're going to go to the negative side of our number line. We're going to go to the left. So what we're going to do is we're going to rewrite this 3.16, and we're going to count to where we want this decimal to go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would be times 10 to the 10th, negative 10th. Make this more of a 0. So 10 to the negative 10th tells us that our decimal point, whenever we are ready to multiply, is going to go this way. How does that work? We know how negative exponents work. Negative exponents means you do this, right? That's what this equals. Well, 10 to the 10th is going to be, it does equal 1 with 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Let's put our commas in. That is what that equals. 10 to the negative 10 does equal this. And when we multiply it times the whole number, 3.16 over 1, we end up with 3.16 divided by 10 billion. And if you put that in your calculator, the answer you get is this. So this is valid. Using the negative exponent does this and equals this. So when you have a decimal that you want to write shorter, you count the decimal backwards and you use the negative exponent. When you have a big number that you want to make smaller, you count the decimal forwards towards your number that you want to use. I'm sorry, I guess that's the forwards and backwards doesn't really make much sense to you. All right, when you move the decimal to the right, you're going to use a negative exponent. Okay, when you move it to the left, you're going to use a positive exponent, because when you move it to the right, you have to make it smaller when you multiply. When you move it to the left, you're going to have to make it bigger when you multiply. Okay, so if you can remember that, positive means you're going to make the number bigger, and negative means you're going to make the number smaller. All right, so positive equals bigger, and negative equals smaller for exponents, which we sort of already knew. We're just reiterating. This is just another way that exponents are used in the real world. So all the stuff you're learning, depending on what you end up going into, you might use, and you might use it all the time. And you'll eventually see this if you go into, if you take any science classes, chemistry, physics, you'll eventually see this, and it'll cross over into your science work. So that's how scientific notation works. Okay, so let's clear this page and do some practice problems. Take these notes down. I'm going to clear the page. All right, so practice problem number 1. We have 0. This is 74.1. Oh, same number. 0.00316. We need to write that in scientific notation. Okay, so we know we want to put the decimal point here. So that's going to be 3.16 times 10, and we're going to count 1, 2, 3, 4. Negative 4, because this number has to get smaller, so it needs to be negative. Easy peasy, right? That's all that is. 74.2. Now we're going to take this number and we're going to write it in scientific notation, or it's written in scientific notation, and we're going to extrapolate it, right? It is 0.0 and it already has a scientific notation added to it. And we need to write that more succinctly. We need to rewrite this. This number has changed. We need to rewrite it with the correct number. We need to recondense it. Apparently this number has changed. So we put our decimal place where we want it. And we go 1, 2, 3, 4. And we're going to increase this by 4. Okay? Because what we needed to do, let me show you. What we needed to do was, we had 10 to the negative 7. So we did 10 to the negative 4. Negative 7 and negative 4 equals right? So we just added our exponents together, just like we always do. So you can adjust a number. If you don't have all the zeros in there, you can readjust it and add it in, and it's just fine. It's 74.3. We're going to write this one in scientific notation. Same number. And this is positive 7. So now we need to change it. So this becomes 3.16 times 10 to the positive 7, and 1, 2, 3, 4. That's going to be negative 4, right? So this becomes 3.16 times 10 to the third, because 7 and negative 4 is 3. So you treat this just like you've always treated exponents. Always, always. Only now we're doing this when we have a whole number instead of a variable. It works the same way. 74.4. We have 3 examples here to write. So our first one is 47,800. We need to write that in scientific notation. So we are going to begin by writing where we want the decimal place, 4.78, and then counting 1, 2, 3, 4 to where that decimal is over here. This number is going to have to get bigger to equal this, so the 4 is positive. All right, we have another example. We have 47,800 equals, or I'm sorry, not equals, times 10 to the negative 7. All right, well, we want to put the decimal here, so 4.78 times 10 to the negative 7 times 10 to 1, 2, 3, 4, 10 to the positive 4 equals 4.78 times 10 to the negative 3, because negative 7 and positive 4 is negative 3, and that would be your answer. We have one more example here. 47,800 times 10 to the positive 7. We don't want to rewrite that smaller, So we put our decimal where we want it, and we write times 10 to the positive 7 times 10, and we count 1, 2, 3, 4, and it's positive 4 again. And this time, 4.78 times 10, 7 plus 4 is 11 to the 11th. It's just the same way we've always done exponents. When they have the same base, well, then we can add and subtract the exponents based on their value. Okay? Easy peasy. And that is all I have for scientific notation. This is all that you need to know for scientific notation. If you have any questions, please feel free to write them down in your notebook and bring them to class, or text me, pick if you get stuck.